Hello everyone. In this video, we're going to take a look at how to find the inverse of a matrix. Okay, so if we have a matrix A and we multiply it by another matrix, say matrix B, and we get what is known as the identity matrix, then it simply means that B is the inverse of matrix A. Now, to take this a bit lower, if I have a number 5, okay, and I multiply 5 by its inverse, which is 5 to the power minus 1, this is going to give me, this is indices, right? Sorry, this is indices. The bases are the same, so what do we do to the exponents? We add them. So 5 to the power 1 plus negative 1, and this will give me 5 to the power 0, which is equal to 1. Right, so what we know is if I multiply a number by its inverse, then I'm going to get 1. If I have a matrix and I multiply it by its inverse, I should get 1. But these are matrices, and the one representation in terms of matrices is giving us the identity matrix I. Alright, and the identity matrix is a square matrix whose diagonal entries are all 1s and everywhere else is equal to 0. Alright, so once again, this will be the same as A inverse times A. When it comes to multiplication of a matrix with its inverse, the answer is always equal to the identity matrix, and so it doesn't matter the arrangement. A to the power minus 1, which is the inverse of A, times A is always going to be the same as A times A inverse. It doesn't matter the arrangement. But if they are not inverses of each other, then A times B is not necessarily the same as B times A. Now, with that being said, to find the inverse of a matrix, there are two entities that are required. All right, so to find A inverse, we need to know what is known as the determinant of a matrix, and which is giving us the absolute value of matrix A. Then the second entity that we need to know is the adjoint or the adjugate of the matrix. All right, so in short form, we write ADJ of A. Now, depending on the size or the dimension of a matrix, the adjoint or the way you find the adjoint of the matrix varies, and the way you find the determinant also varies. All right, so we'll look at a simple one first, and then we move on to a 3 by 3 matrix. So to find the inverse of a 2 by 2 matrix, okay, for example, if I have matrix A given as A, B, C, D, then first we need to find the determinant. We need to find the determinant first because A inverse is giving us 1 over the determinant of A times the adjoint of A. And so if the determinant is equal to 0, okay, so if the determinant is equal to 0, then we're going to have A inverse is equal to 1 over 0, and 1 over 0 is undefined. So we're going to have undefined times another matrix, and that will make it undefined. So our inverse will not exist because the results that we're going to get is undefined. All right, so if the determinant is equal to 0, then there is no need finding the adjoint because what we're going to look for does not even exist. Right, so if the determinant is 0, then A inverse does not exist. And if the inverse does not exist, then we say the matrix is singular or non-invertible. But if the determinant is a non-zero number, okay, if the determinant is not equal to 0, then we have 1 over non-zero number, which is a defined number. So it means that the inverse will exist. So the inverse exists, and the matrix is said to be non-singular or invertible. All right, so if I have my matrix A, which is A, B, C, D, now to find the determinant of a 2 by 2 matrix, absolute value of A, this is equal to the absolute value of A, B, C, D. This is simply multiplying the product on the leading diagonal, AD. subtracting product on the other diagonal. Okay, so minus BC. And that gives you the determinant of a 2 by 2 matrix. Multiply the component on the leading diagonal minus component on the other diagonal. All right. Then to find the adjoint of a 2 by 2, we swap the positions of components on the leading diagonal, negate the components on the other diagonal. All right. So instead of the leading diagonal being AD, we now have DA. Then instead of having B here, we're going to have minus B. Instead of having C here, we're going to have minus C. Now, our next video will explain why we need to swap the position of members on the leading diagonal and negate members on the other diagonal. So please check out the next video. It explains why we need to do this when we're finding the adjoint of a 2 by 2 matrix. So once we have the adjoint and we have the determinant, then we can find our inverse, which is equal to 1 over the determinant times the adjoint of our matrix. So this is equal to 1 over AD minus BC times D here minus B minus C and then A. So the whole thing becomes D all over AD minus BC minus B all over AD minus BC minus C all over AD minus BC and then A all over AD minus BC. And that gives us the determinant of matrix A, whose components are A, B, C, D. Okay, so let's look at if we have matrix A giving us 1, 2, 3, 4. Then to find the inverse of matrix A, first we find the determinant, and if the determinant is a non-zero number, then we find the adjoint. But if the determinant is 0, then we conclude that the inverse does not exist, and therefore matrix A is known as, very good, singular matrix or non-invertible. So determinant of matrix A, which is giving us absolute value of A, so 1, 2, 3, 4. To find the determinant, we multiply members on the leading diagonal. So we have 1 times 4 minus members on the other diagonal, 2 times 3. All right, so 1 times 4, that will give us 4 minus 2 times 3, that will give us 6. And this is equal to minus 2. All right, then the next thing to find is our adjoint. We find the adjoint because the determinant is a non-zero number. Therefore, the inverse exists, and A is said to be invertible or non-singular. And we said that to find the adjoint of a 2 by 2, we simply swap the positions of members on the leading diagonal. So instead of the leading diagonal reading 1, 4, now it's going to read 4, 1. Then we negate members on the other diagonal. We do not swap them, we just negate them. So minus 2 here and then minus 3 here. Right, so our inverse, which is 1 over the determinant times the adjoint, becomes, our determinant is minus 2, so 1 over minus 2 times our adjoint, which is 4 minus 2 minus 3 and 1. So this will give us 4 times minus 1 over 2 minus 2 times minus 1 over 2. Then we have minus 3 times minus 1 over 2, 1 times minus 1 over 2. And this is equal to minus 2 here. Then we have positive 1. We're going to have positive 3 over 2, which is the same as 1.5. Then we have minus 1 over 2, which is the same as minus 0.5. Okay, now let's see if we can get the same thing under Python. All right, so we have our matrices. We have already input our matrices in our array in Python. All right, so what we'll do next is to do this inverse. All right, and then the function for finding inverse in Python is giving us len arg. Alright, so len means linear, arg means algebra, len arg dot inv, and then the name of your matrix. So linear algebra, but finding the inverse of matrix A. So that is what we're going to do in here. So instead of the addition, the add, the subtract, the transpose that we have been doing, finding the inverse, we simply replace the add or the subtract with len arg dot inv. Right, so we have print into bracket go-cart dot len arg dot inv, and this takes only one argument, which is to find the inverse of just one matrix. All right, and so if we run this, we get in minus 2, 1, 1.5, which is the same as 3 over 2, and minus 0.5, which is the same as minus 1 over 2. And that is the same thing that we got when we did the pencil and paper approach. All right, now let's look at if we want to find the inverse of matrix B. Right, so we have print into bracket go-cart dot len arg dot inv into bracket matrix B, and we run it, and we're getting minus 4, 3, 3.5, and minus 2.5. Now we could also do this by pencil and paper approach and see if we can get the same thing. All right, so matrix B is giving us 5, 6, 7, 8. All right, so if we want to find the inverse of this matrix, first of all, we find the determinant of matrix B, which is giving us absolute value of B, so 5, 6, 7, 8. All right, and this is equal to product of members on the leading diagonal, 5 times 8, minus product of members on the other diagonal, 6 times 7. Right, so 5 times 8, which is 40, minus 6 times 7, 42. Right, so 6 times 7, that will give us 42. All right, so the answer is equal to minus 2. And this is a non-zero number, so it means the inverse exists. So we find the adjoint of matrix B, and for a 2 by 2, we have the shortcut, which is swap the positions of members on the leading diagonal. So instead of 5, 8, we're going to have 8, 5, and then we negate the other component. So minus 6 and then minus 7. You do not swap them. It's only the leading diagonal component that you swap, but the rest you negate them. So our inverse is going to be 1 over the determinant of B times the adjoint of B. And this is minus 1 over 2 times the adjoint, which is 8, minus 6, minus 7, and 5. All right, so every member of this adjoint gets multiplied by minus 1 over 2. So minus 1 over 2 times 8, that will give us minus 4. Minus 1 over 2 times minus 6, that will give us positive 3. All right, and then we have minus 1 over 2 times minus 7, that will give us 7 over 2, that is equal to 3.5. Then we have minus 1 over 2 times 5, that will give us minus 5 over 2, which is equal to minus 2.5, just like we had it when we use Python. All right, so it doesn't matter what you're using, the results must always be the same. Now, if we are trying to find the inverse of A using Excel, then we follow the same approach that we've been doing when we're trying to find the addition, the subtraction, the transpose, and then the product. All right, so to find the inverse of matrix A, we select the area which represents the dimension of our resulting matrix. right? And then because it's a 2 by 2, we select a 2 by 2 grid. Every formula in Excel start with an equality sign. So equal to, we're finding the inverse of a matrix. And for Excel to find the inverse of a matrix, its function, or the inbuilt function that does the inverse of a matrix, is called M inverse. It's called M inverse, all right? So instead of just inverse, we input M inverse, all right? So this is equal to M inverse, and it also takes only one argument. So we open it and we input the matrix that we want to find the inverse of. We close it and press Ctrl Shift Enter. Now if we do that, we get a minus 2, 1, 1.5, which is the same as 3 over 2, and then minus 0.5, which is the same as minus 1 over 2, and that is exactly the same thing that we got when we did try find the inverse under the pencil and paper approach as well as under the Python approach. So we have minus 2, 1, 1.5, and minus 0.5. Now if we want to find the inverse of matrix B, so inv of B, we do the same thing. Select the area that represents the dimension of your resulting matrix, which is a 2 by 2. And every formula in Excel begins with the equality sign, so equal to, and then we input the function that does the inversion or the inversion of our matrix for us, which is M inverse. Open the bracket, then we select the matrix that we want to find the inverse of, close it. Now you do not press enter. Depending on the machine that you're using, the combination, the right combination is Control Shift Enter, right? But some machines also allows you to just press enter and you get your value, right? So we have minus 4, 3, 3.5, and then minus 2.5, which is the same thing that we got when we use the pencil and paper approach as well as when we use Python. All right, so it doesn't matter which approach, which tool you are using, the results must always be the same. If the results are not the same, then it means you're doing something wrong somewhere. All right, so see you in the next video.